In this video, we're going to look at some quick worked examples of rationalising the denominator. Let's start off with 1 over root 2. So at the moment, we have an irrational number in the denominator. If we want to write this with a rational denominator, we simply multiply now the bottom and the top of the fraction, so the denominator and the numerator, by root 2. Multiplying the numerator and denominator by the same quantity will not change the value of the fraction. So in the numerator, 1 times by root 2 is going to be root 2. Then in the denominator, root 2 times by root 2 gives me 2. So if we wanted to write 1 over root 2 now as a fraction with a rational denominator, we'd have root 2 over 2. 2 is a rational number. Let's look at another one. Let's say we've got 7 over root 5. All we need to do here is multiply top and bottom of the fraction by the surd. So we're going to multiply the numerator by root 5 and the denominator by root 5. So in the numerator, I'll have 7 root 5. In the denominator, I'll simply have 5. So this gives us now our fraction with a rational denominator. Let's say instead of 7 over root 5, I had 7 over 3 root 5. All we would do again is multiply now the denominator and the numerator by root 5. We don't need to multiply it by 3 root 5. If you like, you could see this, and I'll just scribble this here, 7 thirds multiplied by 1 over root 5. So if you want to see it that way and just rationalise this, you can do and multiply them back. I'm just simply going to go ahead and write this out. So we got now 7 root 5, and then we've got 3 multiplied by root 5 multiplied by root 5, which is going to give us 3 multiplied by 5. So we just need to tidy this up, and we can say now that that will be 7 root 5 over 15. So we have now our fraction with a rational denominator. Let's look at one more. Let's say we had now 4 over 3 root 2. I'm going to multiply the denominator by root 2 and multiply the numerator by root 2. So I end up now in the numerator with 4 root 2, and in the denominator I'm going to have 3 multiplied by root 2 multiplied by root 2, which is just going to give me 2. Now I can see that this is going to give me 4 root 2 over 6, which I can go ahead and cancel to 2 root 2 over 3. So all I've done is cancel the form of 6. You could do it at this stage with the form of 2, but we would generally give our answer in the simplest form, and that is the simplest form. Okay, let's look at a different type of fraction. So with these ones, what we have now is a single value in the denominator. We have a single surd. Sometimes we might have something slightly different. Let's say we had 1 over 3 plus the root of 2. So we can see here there's no addition or subtraction sign. With this one we do. What we do for this particular example is create the difference of squares. We multiply this by what we call the conjugate, which is the same numeric value, yet the sign has changed. So we multiply top and bottom of the fraction, so the numerator and the denominator, by 3 minus root 2. So in the numerator, we're going to have 3 minus root 2, and then in the denominator, I'm going to expand this out and show that this can be written now as the difference of squares, and then we'll end up now with cancelling terms. 3 times by 3 is 9. Then I'm going to have minus 3 root 2. Then I'm going to have plus 3 root 2, which is going to cancel out. And then I'm going to have now root 2 times by root 2. We've got a negative, so that will be now minus 2. We can see these two terms cancel out. So we have 3 minus root 2 over now 9 minus 2, which is 7. So all we've done is rationalise the denominator by multiplying now the numerator and the denominator now by the opposite. Let's say we had now 2 over 2 minus root 3, and we wanted to rationalise. Multiply the denominator by 2 plus root 3. If we're going to do that to the denominator, we must do that to the numerator, as if I don't, it will alter the value of the fraction. So we'll have 2 lots of 2 plus root 3. I'm not going to expand that just yet. Then in the denominator, we're going to end up now with 4. Then we're going to have plus 2 root 3 minus 2 root 3, and then we'll have now root 3 times by root 3, which is 3, and that will be a minus. So we end up now cancelling these two terms in the middle, and that gives us our difference of squares. So we've got now 2 plus now for root 3, and that's going to be over 4 minus 3, which is 1. So we can simply write this as 2 lots of 2 plus root 3. That would be in its simplest form, but you wouldn't be penalised for writing 4 plus 2 root 3. The reason I didn't expand the brackets is simply because if I had now some value in here that I could cancel off, I'd just go ahead and do it. So for example, if this value is 4, 2 over 4 is going to give me a half, rather than expanding it and then tidying up later. Let's finish with one more. Let's say we've got now 4 plus root 6 in the numerator. Then in the denominator we have 3 minus root 2. So we're going to now rationalise this, multiplying now the denominator by 3 plus root 2 and now the numerator by 3 plus root 2. So if we now look at the numerator, 4 times by 3 is 12. Then we're going to have now plus 4 root 2 plus now the 3 root 6, and then we're going to have now on here root 6 multiplied by root 2, which is going to give us root 12, or we could write this now as 2 root 3. It's entirely up to you. I'm going to write it as 2 root 3, and again, depending on the exam board, will depend on the amount of work that you need to show. Let's now look at this one right here. 3 times by 3 is going to give me 9. Then we're going to get plus 3 root 2 minus 3 root 2, and we will see that these will cancel, minus now, and we're going to have root 2 times by root 2, which is 2, and we can just go ahead and tidy this up. So it's still going to look a little messy, so we got 12 plus 4 root 2 plus 3 root 6, and then we got plus 2 root 3, all over now 9 minus 2, which is 7. So as you can see, that turns out to be a bit of a mess, but we've used the correct technique to just now express this with a rational denominator. Remember, when we're talking about a rational denominator, we're talking about now a value that can be written as a over b, where a and b are integers. 7 is rational. 2 root 2 is irrational. If we have now root 5 is irrational. So that's rationalising the denominator, and we've looked at a few different examples.